Take 2 of these and call me in the morning. Who hasn't heard that before? But how many of us, including physicians, really know how drug companies make pills? Medications are essential in the treatment of illnesses. It begins by a grinding process where the active ingredient in a tablet or pill is ground and mixed with a binding agent. The quantity of the ingredient needed to be ground is transported to the dryer in this container. Like all the other equipment, this container is made of stainless steel so as not to contaminate the product. The temperature of the dryer and the airflow are programmed with this interface. The granulation has to be dried at 40 or 50 degrees centigrade before being shaped into the desired tablet form. Molding of the pills is done by this press, which crushes the powder. The press exerts a pressure varying between 2 and 5 tons. Here's how the molding is done. The press magazine distributes the powder in molds made of steel discs. 2 stampers, one above and the other below, crush the powder and form the pill. Here the press operates at full capacity. It can produce 5,000 pills per minute. Quality testing is carried out on 5 pills every 15 minutes. Their hardness is verified with this apparatus in which jaws crush it with a force varying between 2 and 20 kilopascals. The pills must now be coated so that they won't crumble. A coating solution made of water and coloring pigments is used. This is the coating unit. It can hold 160 kilos of pills. 3 plastic tubes, positioned at strategic points, will spray the solution onto the pills in motion. The quantity of dry pills to be coated is put into the unit. Then the door of the coating unit is carefully closed. A drum turns inside the unit, tumbling the pills. Then nozzles spray the solution in the form of a mist, which quickly dries, preventing the pills from sticking to one another. This spraying operation lasts 40 minutes. Here we can compare pills. On the left are those made only of powder, while on the right are the spray-coated ones. The finished pills move down a chute to enter a counter prior to filling bottles. They are lined up in grooves to make filling easier. The quantity of pills to be placed into bottles is controlled by this automated unit connected to the counter. In this instance, 500 pills are poured into each bottle. This plant also makes capsules where the ingredient is not crushed but encapsulated in a gelatin casing. The distributor places the 2 halves of the capsules in the proper position for filling, with the wider half situated above. The top and bottom portions of the capsule are separated. The lower half is then filled with powder. When well filled, the 2 halves of the capsule are joined together. The completed capsules are then ejected from the filling unit. Then, via centrifugal force, they are positioned for the packaging process. The weight of each capsule is verified by this counter. Each capsule must have the precise weight. And the final step is packaging. A sheet of transparent PVC is heat embossed, forming an impression to receive capsules. Then a pre-glued aluminum foil sheet is adhered to the back side, sealing everything in. This plant turns out millions of pills and capsules every year. This is what Italian traveler Marco Polo brought back from China some 700 years ago. Since then, pasta has spread all shapes and sizes, and so have we pasta lovers, but that's another story. Who would have thought that pasta is actually Chinese in origin? When Marco Polo returned to Venice in 1295, after spending 24 years in the Far East, he brought back with him Chinese pasta noodles. So quickly popular did pasta become that by the 15th century, it occupied a prime position in Italian cooking. In this same era, commercial production began in Naples. Italians today favor macaronis and raviolis with garlic and cheese. Pastas are generally made from semolina and water. These silos contain more than 30,000 kilos of semolina derived from durum wheat, a hard, amber-colored wheat. The semolina heads toward the high-speed premixer, where it will be vigorously mixed with water for 5 to 10 seconds. This machine can treat between 1 and 2 tons of semolina per hour. The dough is extracted from the premixer and falls into a first blade mixer, open to the air. Then the dough goes into this vacuum blade mixer. The mix is now ready to go through the brass molds. Here's a spaghetti mold and a mold for mafalda, very narrow lasagna. And here are molds used to make lined shells and stars for soups, as well as cresta di gallo. The dough is injected into the mold under pressure. This rotating blade machine cuts some 12,000 rotinis per minute. That's 720,000 per hour. With the dough being still quite fresh, the rotinis are soft. They will dry somewhat on this plate. Now we move to the lasagnas. The dough goes through this brass mold, and the strips of fresh dough, 107 centimeters long, are placed on these sticks to dry at 65 degrees centigrade. They dry vertically so as to retain their nice flat shape. After drying for 15 hours, the strips are then cut in 4, thus making 4 strips measuring 25 centimeters each. To minimize losses and make cutting the dry lasagna easier, scissors trim the dough pieces into equal lengths on the sticks. The long lasagna drying process begins. Once dry, the lengths of lasagnas are finely cut. They're now ready for packaging. To make some other pastas, the mix has to be a bit more worked in order for it to have the required shape. The dough goes through this roller, which gives it the desired thickness. And now butterflies are formed. This mold cuts 7,500 of them a minute, for a total of 450,000 an hour. The sheet of dough is 61 centimeters wide. It is produced in a steady stream and goes right to the cutting mold. The butterflies fall onto this conveyor to dry somewhat. Then they head toward the next production step. Certain short pastas, such as these butterflies and fuzzilis, have to be dried, so then they're put into this full dryer. Coming out of the dryer, the pastas are hard and ready for packaging. Here we see the ever-popular spaghettis being made. As with lasagnas, spaghettis are also dried vertically. Now this automated machine places the spaghettis onto a cutting table and breaks them to the proper length. The spaghettis are now ready for packaging. Exact quantities to be bagged are determined by computer. Then the spaghettis go gently down this chute. The amount of spaghetti going into each bag is transported and emptied out by this moving container. To make filling easier, the spaghettis are properly positioned by this chute. In just 1 minute, this machine can package 10 4-kilo bags. Whenever needed, it can handle up to 60 bags a minute. Pastas are a favorite meal the world over. This plant makes over 100 different products, and every day uses between 60 and 360 tons, or the contents of from 2 to 12 truckloads of semolina made from hard wheat.